Let us look at some characteristics of a microservices architecture. Okay, we'll go through some of the points in detail. Componentization via service. Via service. That means there are different components as per the service. There are as many services as many components. Also, we can think of it. This way, we can decouple and make them independently deployable. As we discussed, microservices are a group of services, each specialized in its functionality. Similarly, if we have similarly, they provide decoupling and independent deployment. We can create temporary services and delete the services once the need is over. This is also possible. What we mean to say is we can create one service, and once the requirement is over, we can remove that service without affecting the overall application. This is a great functionality where we don't have to completely disrupt the architecture of an application. It can evolve without affecting complete application. We can deploy a new service, or maybe we can remove an existing service. This helps in evolving the design with the future needs and changes in business. So we don't have to carry unnecessary functionality, unnecessary code when the business functionality is not required. Okay. So services must interact with each other through a commonly agreed contract such as API. This is the this is the kind of requirement that we get it because we separated the services. What we are saying here is that we'll have services, they are independent, each of them are specialized on their own requirement fulfilling. They can be created and deployed and destroyed anytime, and there must be some mechanism of communication, creating a communication among them. We'll see the other one, organized around business capabilities. So this is again the same concept. Like, I introduce a new functionality to my software, I shall be able to create a new service and integrate it with my existing services. So my application architecture is evolving around the business capabilities. A new capability comes, maybe a new service will come. An existing capability is removed, an existing, maybe a microservice is removed from the architecture. And also, what it means is that we need to have people who manage this. As we discussed, each application's microservice can have its own technology stack, right? Suppose this is in Python, this can be in Java. A team doing this need to have end-to-end full stack capabilities of developing it, maintaining it, deploying it, and delivering it onto the environment. So, what happens is that we need full stack development expertise. Instead of the traditional roles like front end, back end, QA, we need to have a team together, same team together, capable of delivering it as a full stack application. So, not only the application architecture, but also the team's organization need to be around these business capabilities. The third thing that we can see is decentralized governance. Here we can see decentralized governance. We have multiple microservices, right? So they need to be governed. We need to know how to deploy them. We need to know how to make the service up, how to make the service down. And also we need to know how to build the services. Decentralized governance, we talk about like building services in different technology stack. Using a suitable solution is more important than using a unified solution. What we are saying here is that suppose there is some functionality which is can be best done in Python. Say for example, there is a machine learning functionality where a lot of Python libraries are available which are matured and tested by the industry. Now, if your application is not in Python, if it is in some Java or JavaScript or some other language where these libraries are not available, then it is a difficulty for the team to add this functionality. Whereas using microservices application architectural techniques, you can bring in a separate technology stack and still integrate it with your existing application. So the important thing here is that we should not be limited by the technology to achieve our business goals. So a suitable solution is more important than using a unified solution. It also adds complexity in managing the teams, managing the technical stack of the application. So we need to bring some trade off. We'll see the other aspects like decentralized data management. What we are saying here is that Each application, I mean, each microservices can have its own type of database. It can be a relational database, it can be a document database, it can use different tables or different data storage needs. So we can have a decentralized data management as one of the characteristics of a microservices application. Now we can also see some infrastructure automation, some other features like infrastructure automation. What we mean by infrastructure automation is that in the traditional roles, we used to have people who used to build and deploy machines. They install the OS, they install the other software that are required like database, and then other dependencies, and then they apply the our application on top of it, maybe UI component, maybe business component. So there used to be a lot of infrastructure activity that is required to start the work or to do the development activities. Now, in a microservices architecture, we will have hundreds of these small applications, and having them to manually do all the setups and each time to maintain them is a complex task. So we need to find some automated way of using this. This is all we talk about infrastructure automation. And we use a word called pipeline, which talks about from the code we check into GitHub to it gets deployed into the production environment, how it is treated, how it goes through different stages. Like this can be compilation, this can be unit testing, this can be integration testing, this can be quality checks or some other test cases, or threat modeling kind of scenarios are handled, or we can have a lot of static checks, lot of vulnerability checks, a lot of things it goes through. So this is called a pipeline. This pipeline, once it is built, it gets automated from continuous integration, like from the integration test cases to integration in different components to continuous delivery, like it goes and deploys into the production environment, and these are all automated. So, infrastructure automation is one of the aspects of a cloud microservices environment. Now, if you see these microservices, they also provide another challenge in terms of failure handling. We need to handle failures. That means I have these microservices. Now, if this is trying to communicate, this is trying to communicate, this is trying to communicate. Suppose the service is down. So, this will not get a response. That means there is a failure. Or the service may be up, but there is a network breakdown. In such cases, this also will not get any response. There are a lot of reasons why the communication between them can fail. Say, network jitter is one of them, unavailability of an upstream service, or traffic overload, or there are routing errors. So, because of all the routing means here the routing of one service to the another service, each one has its own IP address or DNS, and then their own port number. So, maybe this is not properly configured to route this here, or this may not accept a request from this service to here if it is not properly configured. So, these kind of errors. So, what happens is, in order to solve all this, we need to create a governance of the services. This is called service governance. What the service governance can help us is to find out if a health of a service, that means is the service up or down? Is the health of the service good? Can we restart a service, like restarting a service? Or can we remove a service? Can we make the service down? So this governance of these services is important. Not only that, we also need to know service monitoring. Say, how do we know what is going on in this service? Suppose there is a log file this service generates, there is another log file this service generates, there is another log file this service generates. When a user request comes through, it has to go through all these services. So all of them log their own events without knowing from where it has come, what it has gone. So there is different techniques on how we do a log tracing across different multiple services. So log monitoring and then metrics identification, like what is the CPU consumption, what is the memory consumption, how much space is available, can it store more data or not? And then tracing, like I started a request here, what happened to the request here, what happened to the request here, did it reach here or not? So we need to be able to trace. So all the service governance and service monitoring are important functionality that are required to deploy microservices application. So if you observe, what it means is we if we separate this as a uh, logical grouping, If you see, initially we have infrastructure providers. It's only infra, bare metal. There is a middleware providers. There is an application provider, right? Now, the moment a developer starts involving to other layers other than the application development, the business logic gets diluted, and also it becomes difficult to debug and then port it from one OS to another OS. A lot of different difficulties will come when we want to migrate them. Now, by using microservices architecture, what we are saying is you focus on the development of your business logic. The remaining part will be handled by different teams, by the infrastructure provider or the cloud provider or the environment provider to take care of these things. Like they provide services, they like service governance, they provide service monitoring tools, they provide continuous deployment tools, they provide communication among different services. So all those features are part of the environment that you start using it from day one instead of you investing by your developers or in your expertise into that. So it clearly gives a good advantage for the application developers where they focus on the clear business, the need of the hour. They can create a service, they can destroy a service later on if it is not required. So this way they are able to handle the business demands much better way by not involving into a kind of difficult environment issues later on. Thank you.